All right, so we have negative 4 comma 3 is a terminal point of angle theta in standard position. So if we draw that out, here's our grid, negative 4 comma 3, that's going to end up here in quadrant 2. There's our angle theta in standard position would be right there. Now we're going to try to find out all the angles in radians that are going to fit with this. Now this builds on something you've done before. If you were asked this same question in degrees, it would be a grade 11 question. So how would you do this if it was a grade 11 question in degrees? Well, you would make a triangle, right angle triangle here. What do we know about this triangle? We know this length is 4, this length is 3, and this angle right in here is our reference angle. And if you draw that triangle, you can go back to grade 10 math and SOHCAHTOA, and how would you figure out what that angle is? How would I figure out that reference angle? Would I use sine, cos, or tan? Tan. You'd use tan. Why would you use tan? So you would write out your equation that tan of my reference angle is the opposite side, which is 3, over my adjacent side, which is 4. And if it was an actual triangle, all your values would be positive. Even though it's negative 4 comma 3, when we're talking about triangle and side lengths, they're all positive values. So whenever you're figuring out a reference angle, you're always figuring things out with positive values. And you might have been told that last year in grade 11 as well. So then how do we find this reference angle? Tan inverse of 3 over 4. Type it into your calculator. Tell me what you get.
Wait, do you want us to do it in radians or degrees?
0.644 if it's rounded. Squiggle bracket 0.644. So there we have an angle in radians. If we know that 1 radian is about 57 degrees, 0.644 is less than 1, we might think this might be around 32, 33, something like that. As an idea, we could check it with our calculator to find out exactly how many degrees it is. Now, if I wanted to find this angle theta here, how would I do that?
Pi minus 0.644.
Does that make sense in radians? Because how would you have done it if you had degrees? If you had degrees, you'd go 180 minus whatever the angle was in degrees. So now we do exactly the same thing in radians, but now instead of 180 degrees, this is pi radians. So when we do that, we get 2.498. Does it say to the nearest tenth of a radian? 2.49 would round to 2.5. Have we solved for everything in the domain that they were asking for? When we go from negative 2 pi to 2 pi, and I often, because standard position starts here at 0, can you see that that includes 0 to 2 pi, once around in the positive direction, but it would also include 0 to negative 2 pi, once around in the negative direction. We haven't counted this angle yet in the negative direction. How would you figure that one out? I'll do it in red.
Pi plus 0.644.
So if you go pi plus 0.644, go to our calculator and get that. I get 3.785, which if I round is 3.8. How come that's close but not quite right? It has to be negative. So I like this idea. I like when you're going in the negative direction to not worry about negatives right now. That I know from here to here is 180 or pi, and then I'm going to have to add my reference angle. And so when we got 3.8 as a positive number, that makes sense that we were just 3.8 is how far we traveled. We just add the negative at the end to indicate in standard position that that is going clockwise instead of counterclockwise. So if you wanted to show your work after you've done it, you could put a negative out in front like that, and that would therefore be the right value, because technically this plus this doesn't equal negative 3.8. And there is a half mark deduction on the final exam. If you're doing math, even if you get the right answer, but do the wrong thing in between, you will lose a half mark, right? Like you're doing 2 times 5 divided by 3 equals 2 times 5 is 10, 10 over 3. If you do this, you would lose half a mark. Even though I know what you're doing. You're just doing part of the work in your head and then writing the answer afterwards. But mathematically, what are you saying? You're saying that 2 times 5 divided by 3 is equal to 10. And 10 is equal to 10 divided by 3. That's not quite true. Even though you just say, oh, I was just showing my work here. But if you say something's equal to something's equal to something and they're not equal to each other, that's a mathematical communication error. Anyways, sorry. Part B. You're given that cotangent of theta is equal to negative 2. And to the nearest tenth of a radian, we're supposed to find all the values of theta that works. Start a new page for this. Well, if we know that cotangent of theta is equal to negative 2, what is tangent of theta equal to? 1 over negative 2. And if you know that, how would we solve this if this was in degrees? What would you do first if this was a grade 11 question? No. Draw it out. So if you say draw it out, where is it going to be? It's going to be in the second quadrant. How do you know it's going to be in the second quadrant? So you're saying this is 1 over 2, and this side has to be negative. Okay? Seems to make sense that you had 2 to the left and 1 up, and that would make the opposite over adjacent be 1 over negative 2. Is that the only place it could be? Where else could it be? Fourth quadrant. Because now you're going down 1 and over 2. Or you could just think of your CAST rule, right? CAST rule says where things are positive. According to the CAST rule, tan is positive in quadrant 3 and they're all positive in quadrant 1. So which are the 2 quadrants where tan could be negative? Quadrant 2 and quadrant 4. So the first thing we're going to do is we're going to think of our CAST rule, and drawing a picture is very helpful because in both of these pictures we can make a triangle, and those triangles are identical because they're both 90-degree angles. They both have a height of 1 and a base of 2, and you could draw your reference angle. Does it make sense that those reference angles are the same no matter which triangle you look at? Because those triangles are the same. So we could find our reference angle, and again, when you're solving your reference angle, it's just like it was a regular right-angled triangle from grade 10 where the opposite side is 1. We're not worried about the negatives because we're dealing with an actual triangle and its actual lengths. And when you figure out that reference angle, to decide, should I change my calculator to degrees or to radians? This is in radians, so we'll keep it in radians. tan inverse of 1 over 2 gives us 0.464. Approximately. Yeah. We don't want to round anything too early. In fact, since I'm going to use this reference angle for a number of things, how many people have used the store button on their calculator and know how to use it? Okay? So what we just did was tan inverse of 1 divided by 2 to get our reference angle. See 0.464. Right above the on button is your store button. And what that store button can do is you can store that answer as any letter you want, or even as X. I often choose X because it's the quickest one to push. But if you wanted to store it as A or B, or if your favorite letter is C, you can do that. The reason that's nice to do is now when we want to find out what are these angles between 0 and 2 pi and between 0 and negative 2 pi, we need to figure out two positive angles. Can you see that this first one's going to be pi minus our reference angle? And can you see that this one is going to be 2 pi minus our reference angle? The nice thing about having that value stored is we can go pi minus x, and it will get it that way for us. And we can go 2 pi minus x and get it that way for us as well. Some of you with a newer operating system, you know how you can just go up and actually push enter on an answer that you have. That works as well. So there's a couple of ways to get these answers in a shortcut form. So you have 2.7 and 5.8. Those are our two blue answers in the positive direction, but our domain says from negative 2 pi to 2 pi, so we also have to think about going in the opposite direction from 0 to negative 2 pi. Can you see you'd have an angle here and an angle here? The first red one, I think backwards, I think this is just like in quadrant 1. Does it make sense that that will just be our negative reference angle? So what was our reference angle again? We look at our computer here, calculator, 0.46. So rounded, that'll be 0.5. And the other one, can you see that it's going to be pi plus our reference angle? So I go to my calculator, I can go pi plus x, 3.6. Both of these will be negative answers. So the questions you can do for this one are numbers 13 and 14.